In order to understand potential, let us take some examples. Take a rubber band, tied it at this end and stretch it at this end. Now we release it. Rubber band regain its original position. What has happened is when we stretch it, a work is done, which is stored as potential energy. When released, this potential energy is converted into kinetic energy, used to regain its original position. We take more examples. A coil, when stretched and then released, regain its original position. An object is taken from ground to this height dot and released, come down to its original position. A bow, when stretched and released, arrow. In all the above examples, work done is stored as potential energy, then converted into kinetic energy. Hence we can define potential as capacity to do work. SI unit is joules. An iron sphere of mass 10 kg has the same diameter as an aluminium sphere of mass as 3.5 kg. Both spheres are dropped simultaneously from a tower. When they are 10 meters above the ground, they have the same A. acceleration, B. momenta, C. potential energy, D. kinetic energy. Since acceleration due to gravity is independent of mass, hence acceleration is the right answer. A girl is carrying a school bag of 3 kg mass on her back and moves 200 meters on a leveled road. The work done against the gravitational force will be G equals 10 meters S2, A. 6 times 103 J, B. 6 J, C. 0.6 J, D. 0. Since girl carrying bag overhead, weight acting vertically downwards, perpendicular to the motion of girl, hence no work done. Answer is D. Let us have two bodies A and B, both of mass m, are taken to position C and D traveling a different route of a height h. What is the potential energy of both? Since potential energy depends on the initial and final position, therefore, PA of both equals mgh. Let a ball rolling down on an inclined plane. At the top of the hill, the ball has potential energy due to its height. As it rolls down to bottom, the potential energy is converted into kinetic energy. Total energy through the motion always remains constant. That is, PE plus KE, top equals PE plus KE, bottom. Here KE at the top equals 0 and PE at bottom equals 0. Therefore, PE at the top equals KE at the bottom. Hence, the law of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. This means that the total energy of an isolated system remains constant over time. PE plus KE equals total energy ME. PE plus KE equals E. This equation shows that the total energy remains constant, but the forms of energy change. Here we have a 100-meter race. Each one will cover 100 meters. The work done is the same, however, winner is only one who has taken less time than others to do the same work to run 100 meters. But rate of doing work by each is not same, hence, if power is P, work done is W, time taken is T, then we define rate of doing work as power, that is P equals W upon T, or P equals 1 joules per second equal to 1 watt, is the SI unit. 1 watt is defined as the power consumed if 1 joule of work is done per second. 1 watt equals 1 joule per second. Some larger units, 1 kilowatt equals 1000 W or 1 kilowatt equals 1000 joules per second. Reason out whether or not work is done in the light of your understanding of the term work. 1. Swimmer is swimming in a pond. When swimmer applies a force to push the water back, by Newton's third law moves forward, hence a work is done by swimmer. Second question is, a donkey is carrying a load on its back. While carrying a load, which is acting vertically downwards, but movement of donkey is perpendicular to it, hence work done is 0. A windmill is lifting water from a well. In lifting water from well, windmill is doing a work against gravity, hence work is done. A green plant is carrying out photosynthesis. When sunlight falls on a leaf of a tree, a chemical reaction takes place, without any displacement, hence no work is done. An engine is pulling a train. A force is applied to pull a train. This results a forward displacement, hence a work is done. A sailboat is moving due to wind energy. Wind energy applies a force on the sailboat to displace boat in the forward direction. Hence, work is done by wind on the boat. 4 men lift a 250 kilograms box to a height of 1 meter and hold it without raising or lowering it. A. How much work is done by the men in lifting the box? B. How much work do they do in just holding it? C. Why do they get tired while holding it? G equals 10 meters s squared. Work done in lifting a box equals mg times h equals 250 times 10 times 1 equals 2500 J. In just holding the box, muscle force is used against gravitational force, with no displacement, hence no work is done. Since muscle force is used against gravitational force, hence get tired to hold the box. Which one of the following is not the unit of energy? A. Joule, B. Newton meter, C. Kilowatt, D. Kilowatt hour. Answer is kilowatt, which is the unit of power. A pump lifts 10 kilograms of water in 2 seconds to the top floor of a house from the ground. The height of the house is 10 meters. What is the power of the pump? Given that M equals 10 kilograms, T equals 2 sh equals 10 meters, to find power P. P equals W upon T equals Fs upon T equals 10 grams times 10 meters upon 2 seconds equals 50 G equals 50 times 10 equals 500 watt.